Alright, for this next problem, this one is in standard form. So it's in ax squared plus bx plus c equals 0. So we can read off our values for a, b, and c. So a in this case is 2, b is negative 4, and c is positive 2. Alright, so if we start substituting our values, I have negative times, b in this case is negative 4. We're going to square b, which is negative 4, minus 4 times a times c, all over 2a. So negative 1 times negative 4 is 4. If I square negative 4, I get 16. And then negative 4 times 2 is actually negative 16. Over 2 times 2 is 4. So you notice under my root this time, 16 minus 16 is 0. The square root of 0 is 0. There is no plus or minus 0. 0 is just 0, right? So this is just going to leave me with 4 over 4, which equals 2, 1. So this one has one solution, x equals 2, 1. That'll happen anytime what's underneath your radical is 0. Alright, for number 4, this one is not in standard form. I'm going to add 7 to both sides and get x squared plus 4x plus 7. So now we can read off our values. A in this case is 1, B in this case is 4, and C in this case is 7. So if we start plugging our values in, it's negative times B in this case is a positive 4. We're going to square B minus 4 times A is 1 times C is 7 over 2 times A, which is 1. So this time I get negative 4 plus or minus. Underneath, 4 squared is 16. Negative 4 times 1 times 7 is negative 28 over 2. So if we simplify under the radical, 16 minus 28 is negative 12 over 2. So again, this is where we can't forget things that we've already learned. We can have complex solutions when we use the quadratic formula as well. So remember, if we have a negative underneath, we can rewrite it this way. And then we know that the square root of negative 1, by definition, is I. And unfortunately, we still aren't finished, because that 12, we can simplify that to 4 times 3. And then we know that the square root of 4 is 2. So I have negative 4 plus or minus 2i times the square root of 3 over 2. And lastly, because all of those coefficients are even, I'm going to factor out a positive 2. That leaves me with negative 2 plus or minus I root 3 over 2. And then we can cancel. And finally, the answer is negative 2 plus or minus I root 3. So those are my two solutions. All right? So the next thing that we're going to look at and talk about is this thing called the discriminant. And the discriminant is used to tell us the number and type of solutions that a quadratic equation is going to have. The discriminant, I'm going to call it D, is b squared minus 4ac. So if you notice from our quadratic formula, that b squared minus 4ac, that's the part of the quadratic formula that's under the radical. So to find the discriminant, we pretty much have to start the same way. We still need for our equation to be in standard form, and this one is. And we are also determine what a, b, and c are. So a here is 3, b is negative 4, and c is negative 2. So if I want to determine the discriminant, I'm just going to substitute these values. B is negative 4, A is 3, and C is negative 2. So negative 4 squared is 16. Negative 4 times 3 times negative 2 is 24. And that gives me 40. That number probably looks familiar. These three problems are from the first part of the lesson. This is the first one we worked. This one is number 3, and this one is number 4, so that we can compare. So if you look back at number 1 that we did, you see underneath the root, we got 40. So that's our discriminant. So this discriminant is a positive number. If it's positive, that means that we're going to get two solutions, the plus and the minus. And the number 40 is not a perfect square. So if the number is positive, we get two solutions. If the number is not a perfect square, the type of solutions are irrational. And basically what that means is that we still have a root in the answer. And if you look back at number 1, we did indeed still have a root in the answer. Okay? For the second one, this one again is in standard form. A is 2, B is negative 4, and C is 2. So we're going to substitute negative 4 and square it. 4 times A times C. That's 16 minus 2 times 4 is 8 times 2 is 16. So you probably remember that looks familiar as well from number 3 up here, where we got 0 under the radical. And if you note what happened, we got one solution because plus 0 and negative 0 are the same thing, right? So down here, if my discriminant is 0, we're only going to get one solution, and it's going to be real and rational. I guess we should say over here, these are also real and irrational. And you'll see in the next one why we made that difference. So for this last one, this one is not in standard form. So A is 1, B is 4, C is 7. So if we substitute 4 for B, A is 1, C is 7, we get 16 minus 28, and that gives me negative 12. And that one matched number 4 up here. Sorry, get that pencil. So this one, we got a negative number underneath. We're still going to get 2 solutions. If the number is negative, we don't have to differentiate between rational and irrational. We're just going to say that there are 2 complex solutions. So if you look at this little table here, this is just an illustration to show you what's happening. When we're using the quadratic formula, what we're really doing, this is a quadratic function, so it's a parabola. We're finding what's called the zeros of the function. And the zeros are where that parabola would cross your x-axis. So if you look, b squared minus 4ac basically says if the discriminant is negative in this first one, less than 0, then the parabola never touches the x-axis. So that means there's 2 imaginary or complex solutions. If the discriminant is equal to 0, the parabola only touches the x-axis in one place, so we have one solution. And if it is bigger than 0 or positive, then we care whether or not it's a perfect square. If it's a perfect square like 1, 4, 9, etc., there are 2 real rational solutions. And if it's a positive number but it's not a perfect square, it's 2 irrational. All right. So the next thing we're going to look at is a problem that is modeled by a quadratic function. And we've looked at one similar to this before. An object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second, and the height above the ground, h in feet, of the object after t seconds is given by this equation. It wants to know how long, so of course we're going to be looking for t. After the object is thrown, will it strike the ground? So what we have to know for this problem is if the object is on the ground, then that means the height is equal to 0. And of course in this problem, height is represented by the h of t. So if I take my model here, we're going to be solving for t, and what I know is h of t is equal to 0. So we're going to replace this entire thing will become a 0. And basically what we end up here is a quadratic equation in standard form. Now you can use the quadratic formula right from this step if you want. I happen to notice that all of these coefficients are evenly divisible by 4, and just to go one step further, to make that lead term a positive, I'm going to divide every term in my equation by -4. If you don't recognize that they're divisible, you don't have to do this step. You'll get to the same place. -16 over -4 leaves me with positive 4t squared. 12 over -4 is -3t. And 200 divided by -4 is -50. So what that did for me is just make those coefficients a little smaller, maybe a little easier to handle. Okay? So now that it's in standard form, we can read off A, B, and C. A in this case is 4, B is -3, and C is -50. Alright, so we're going to start plugging in. Now normally we start writing x equals, right? My variable in this particular problem isn't x, it's t. So I'm going to write t equals -b plus or minus square root of b squared minus 4ac over 2a. And now we can substitute. My b is -3. Then I'm going to square the b, minus 4 times a times c, and 2 times a. So negative times a -3 leaves me with a +3. Underneath, -3 squared is going to be 9. -4 times 4 times -50 is 800. Over 2 times 4 is 8. So if I collect those terms, 9 plus 800 is 809 over 8. And I'm just going to split my two cases from here. If you look back at our instructions, it says round to the nearest tenth of a second. So don't worry about trying to break that huge root down. Just separate your two cases, and then because we're going to be rounding anyway, we're just going to enter it into the calculator this way. 3 plus square root of 809 divided by 8. And I got 3.93, which to the nearest tenth, this is my tenth, would just be 3.9. And my second one, if I entered 3 minus square root of 809 over 8, I got -3.18. We don't have to worry about that rounding because this is an application problem and we know that time can't be negative. So that tells me that the time after the object is thrown for it to strike the ground will be 3.9 seconds. All right.